Hello and welcome to another webinar from EMAG. We are here in the webinar studio in Eislingen, and we are very happy to give you some insights into EDNA IoT, as well as a good introduction to data-optimized manufacturing. At this point, please feel free to use the question form to ask us any questions, and we will try to answer them during the webinar at our best knowledge. I think it's very important to know with whom you will spend the next couple of minutes together, and that's why we have prepared a brief introduction. So my name is Miriam Hess. I am an IoT consultant since the beginning of the year. And to my left, I have Johannes Riedel, and I will hand you over to him so he can introduce himself.
Thank you, Miriam.
You're welcome.
My name is Johannes Riedel. I am with EMAG for 8 years now, and 5 of them I spent with studying. And since 2020, I work as an IoT commissioning engineer. So it's my role to install and configure our EDNA IoT solutions on your machines.
Thank you. So now you know who is guiding you through the webinar. And speaking of webinars, here's a short commercial block on our own behalf. So please take a look on our website. Here we have the EMAG Media Center, and we already made many webinars, machine-related topics, but also IoT-related topics. So if you enter the search term IoT, you will find topics such as IoT, the factory of the future is connected, or EDNA Health Check, reduce your risk of default with predictive maintenance. Feel free to take a look, it's worth it. So today we are speaking about data. And in doing so, we will take a look on our agenda for today. So we begin to answer the question, where does the data come from and which data sources exist? This will lead us to the topic data access. We will take a closer look on communication protocols such as OPC-UA, MQTT and REST. Additionally, we will discuss CSV export. After that, we will spend some time on data usage and visualization. On the one hand, we will take a look on EDNA IoT Solutions, and on the other hand, we will give you the basics to process optimization. We finish off with a conclusion and perspectives. Before we get started, a short note on the procedure today. As you can see, no machines are with us today. Nevertheless, we want to give you insights how you can get the data which is gathered in your EMAG machine. That's the reason why we pre-recorded some videos, and we will show them to you during our webinar. So I think it's time to fasten your seatbelts and enjoy the show. We start with the first chapter, where does the data come from? Johannes, what are we learning today? The stage is yours.
Okay, thank you, Miriam. So where does the data come from is the first question we are answering today. But before we do that, when we talk about data, we specifically do not talk about any process-relevant data. So all the data that we collect holds information about the state of the machine at any given time. So let's take a look at the picture. On the left side, we see the interface between our machine and our data collecting software, the EDNA Cortex, or Cortex for short. This is our standard use case to collect data from the machine. However, if you, as our customer, have any data in your networks, we can also read them into our database via OPC-UA, REST, MQTT, CSV, and now listed here as well, XML. The IoT core, which is the IPC inside of our machine, has a database installed locally, the MongoDB. It is a NoSQL database and holds the data. To get the data out of the machine, there are multiple ways to do it over the named protocols: MQTT, REST, OPC-UA, CSV, and possible sources for your or destinations could be third-party software, for example, Grafana, ThingWorx, or further MES systems. Today, our focus will be on gathering data, get them out of the machine, and how to use them.
Thanks for the overview. Johannes, let's dig deeper into the world of protocols. What are protocols?
So protocols in transmission technology or data transmission technology, for short, is a set of rules that sender and receiver agree to know how a data package must look like to be successfully transmitted. So it includes some rules, parameters, or any other parts that a signal must have to be successfully transmitted from transmitter to receiver.
Thanks for that. I think it will be exciting for our audience to learn how to use and how to work with the protocols in detail. So let's start with OPC-UA.
All right, then let's take a look. So OPC-UA is the first protocol we want to introduce you to today. It is built up by nodes and namespaces. The nodes can be arranged into so-called node sets that hold the entirety of your data in node set models. And the namespaces provide a closed environment for the nodes. The nodes and namespaces are used to uniquely identify a signal in the model. OPC-UA is a very popular protocol in the meantime, or nowadays. And one thing that is mentioned frequently with OPC-UA is UMATI. UMATI, however, is more a description of a specific set of data that every machine tool should have to better share the same data over you and to compare them to one each other. With our signal set that we provide, we fulfill the UMATI baseware set specifications, but that's only a side note. So now we will take a look at the first video that we prepared for you and check how we can connect via the OPC-UA interface. So for any connection that we show you, we will take the side of a customer and access the interface from a device inside the network where the machine is connected to. For this, we use the router, which is the interface between machine and outside networks. Here we see in an OPC-UA client that I will connect to a machine with the given IP in the network and the port 4840, some security settings, and for the webinar showcase, we chose some easy-to-use authentications. Okay, now on the left-hand side, you can see the node set, which holds the signals. And now we would like to check one specific signal to take a closer look. For this, we chose the piece counter today. So if we check on the top side, you have the namespace and node ID, which identify the signal, and on the bottom side, data type and value. The value here is 682, and the OPC-UA client does not refresh the value by itself. However, there are options to enable a monitoring that then will keep selected values up to date at all times.
Thank you, Johannes. We will discuss the MQTT protocol shortly.
That's right.
But is the same data available via MQTT that we just seen in the OPC-UA model?
So in the video, we just took a very surface level view on the data model. You can say that because OPC-UA is, or the signals in OPC-UA are arranged in this node set model, that there are scenarios where the model holds less data than the interface provides. This can be, for example, if a customer requests only a specific amount of data to be provided by OPC-UA. With MQTT, the interface or the configured signals in the interface will be shared with the MQTT broker, but we'll take a look at that in a second. We are currently working on building a standard model for OPC UA, which concludes the entirety of our data list. So at the moment, MQTT rather holds more data than OPC UA.
So I'm curious what the MQTT protocol looks like.
Okay. Right. MQTT is a message queuing service, so it works with publishing and subscribing. And the central keystone in this protocol is the so-called broker. The MQTT broker is the central distributor of messages, so it can collect data and send data out or publish data. And the MQTT client can subscribe to a MQTT broker. There can be multiple clients subscribing data from the same broker, and each client holds their own connection to the broker. The signals are filtered or arranged within the topics. So each signal holds a unique topic which identifies the signal. One example we have here in the second bullet point. The structure that we use consists of the cortex, like the name of the software for our data collection, the machine serial number, and machine data items, which includes a specific scope of data. There are other scopes of data, but today the machine data items are relevant for us. And the hashtag at the end is a wildcard, which means that any extensions to the topic will be subscribed as well. And if we take a look how to connect to the interface on the machine or from a device next to the machine, we chose a VL4 as a standard machine for the use case because it is well suited for these types of scenarios. So here we see that I open a command shell and I can use the subscription command, which we'll take a look at in the close up here. So the command that I'm using to connect to the broker is a subscription command, which means I want to receive data. The H stands for host, which is the IP address of the device that runs the MQTT broker in our network, in our case, the machine. U and P are username and password, again for the webinar case, and easy-to-use authentication. And -T now is the main part of the command. It holds the topic, where we specify which data we want to publish, to subscribe, sorry. So with the topic, you can specify the data you would like to subscribe. And if we run the video, you will see that we use the topic that we has shown on the slide before, which means that we subscribe to all data that this machine has on the interface. So if we stop the video here again, we can see that there is a runs completed again, which is, as we have shown before, the piece counter in our database, this time with the value 625. And because it's no fun to search for the piece counter in such a big amount of data, we'll show you as well how to subscribe to a specific topic. To do this, we have to replace the hashtag, which is a wildcard, with the specific signal name. And this way we can filter our receiving data to this signal specifically. So now we see that we get only one result of the runs completed of our piece counter, this time with the value 628.
All right, thank you. So, Johannes, the inexperienced user does not recognize much here.
That's true.
So, what do we see here? Why is there so much text, even though I just want one value?
That's a very good question. To answer it, we can take a look at the video again. let's hold here. So for me, it's easy to look at because I know what it is, but you're right, if you don't know what you're looking at, there's a lot of text for just wanting to receive one signal. This is the reason because we send each signal with a bunch of metadata to further differentiate this signal, because there are scenarios where two machines send the same signal in the same database, and then you need the metadata to know which machine this signal came from. We can take a closer look at it. On the very left side, we have a machine data item, which describes the scope of data that we are working with. Next comes a unique ID, which is uniquely created for each entry in the database. Next is a timestamp with date and time, so you know exactly when a signal was created, and the machine ID and machine type, so you know from which machine the signal came from. And then last but not least, the value type and value, which are the actual name and input of the signal in the database. So
all right.
This is the entirety of what you see here. And with MQTT, it's output as a line, which makes it hard to read. That's the case.
Thank you. So we received the first question from our audience.
Excellent.
What data do we see and what range are we talking about?
So the video shows us a very limited amount of different signals, mainly because the signal we see here is always the same. It is a signal that describes if an axis is moving inside of the machine, and during processing the signal is frequently created. Then again, we have taken a look at the piece counter. However, there are many different other signals that can be created. We will take a closer look at them at a further point later in the webinar.
Okay. So the REST protocol is the third and last protocol we have prepared. Therefore, Johannes, you are ready to go.
All right, then let's close the video here and switch over to REST. So REST is now our third protocol we would like to introduce. It is a very basic protocol which is used in a long time span now. Here we work with get and post requests, which means that we get data from the database or we post a request to the database. For this, we use port 5051 in our machines. And I would suggest we just take a look at the video. It's the best explanation that we have. So here, to access the REST API, I use an easy authentication as well. Then on top, we see that we use a post request with a prepared URL. The post means that we can send additional data, additional filters to further specify our answer. Machine data item, again, the scope of data we're working with, and aggregate allows us to put in the filters in the body. So here we directly filter for the piece counter, and the created at means latest first. So our request here is database, give me the latest piece counter. And here we see the JSON format again. Our metadata I briefly talked about earlier. This time it's formatted properly, so it's easier to see what kind of data are actually provided. Again, the unique ID for each signal, a timestamp, machine ID, machine type, value type, and value. So this is the metadata, this time properly formatted.
Okay, so we have the next question from our audience. How do I know the comments I need for the requests?
That's a very good question I failed to mention. The URL that you use to access our REST API, they have to be known. For this case, we provide with each Cortex installation a Swagger API that comes with it. And the Swagger API holds prepared requests that you can use to access our database. And the Swagger API is also available from a device inside the network.
Thank you. So now you have presented 3 protocols. Are there any preferences as to which protocol is best?
Best is a funny word. Usually the customer knows what's best. So we tend to fulfill the customer requests if they want to use a specific protocol. If you have no experience with working with data, whatever, we can help you to start a project and then work on it together. We can share our experiences in this regard. Yeah, so what's best, usually the customer should tell us.
All right, so another question from the audience. Do you have any use cases regarding protocols?
So the 3 protocols are used in different cases, that is correct. The MQTT protocol, because it receives every piece of data live in the command shell, as we've seen, it always displays the latest data, is useful for live visualizations. For example, the dashboards, which we will show you later, they use MQTT to receive the latest data. MQTT is also easy to learn. It has a low threshold for new or for working with it, and it can manage a wide variety of network setups. With OPC UA, the big advantage here is that it's specifically developed for industrial automation usage. So this means you have a great comparability between machine tools in the signals that they share. With REST, the use case would be mainly web or online solutions. Here it is more a request-based protocol, less than a monitoring live data. So you build your request with a specific answer in mind, and then the request is built around the answer you want to get. So it's less a live monitoring tool.
All right. So we have seen with MQTT that new data is read pretty quickly. Is this also the case with the models for OPC UA and REST?
Okay, so read quickly means keeping up to date, I guess. So MQTT, as said before, displays the latest data in the command shell and then can be used to display any visualizations with live data. With OPC UA, this is a similar case, but it's not as visible because the signals and the data behind them, they are stored in the nodes, and each signal has the specific nodes, and in the node set, you can select the value, which then shows you the, or you can select the signal, which then shows you the value to the signal. So here, all the values or all the nodes are always kept up to date as well. And with REST, as mentioned before, it's less a monitoring live data, more than a requesting a specific amount of data, which can also be in the past. Another topic about frequency and data. Usually a database entry gets created when a value changes. And if a value changes in a high frequency, then the database usually about every 100 milliseconds gets a new entry. So that, I hope that satisfies the questions.
For sure. So I would say for orientation, just one further. Yep. Yes. So for orientation, here's our graphical overview we saw in the beginning of our webinar. So Johannes did a great job in explaining MQTT, REST, OPC UA with UMATI, and now CSV export is left. So again, the stage is yours, yep. Johannes.
All right, so CSV export is also an interesting topic because CSV, usually in the same breath mentioned with Excel or spreadsheets, is a great tool to display data or to do some easy analysis or visualizations yourself. And for this, we have an exporter to provide data in this format. On the bottom side of the slide, you see an example of such a file. Here you would have to be a bit careful about what data you want to export because the file can grow in size rather rapidly. We did a test with 7 machines over 24 hours where we collected the production data like stack lights, tool changes, and cycle times. And over the case of these 24 hours, the file had over 100,000 entries. So here you should put the focus on less data and then think before you configure the export. But as mentioned, a great tool for first analysis and overviews.
All right, so EMAG has already developed some of its own standard solution based on the data. Johannes, can you give us a little tour?
Yes, with pleasure. So the first product I would like to share with you, because we as a company with IoT-supported machine tools have, of course, some products as well, is the Cortex Insights, as we call it. This is a easy-to-use interface directly into the machine database, which you can access via the machine or, as mentioned before, with a device in your network. So let's take a look at the machine use case first. On your machine, you can open the IoT platform, which then holds multiple IoT apps you can use. In our case, we check the Cortex Insights now. Here you get a list of your signals in the database listed by their name. And on the bottom side, you can see that there are 28 pages with 15 signals each. Another hint at the scope of our signal lists that we will talk about in a bit. With the filter option, you can check for a specific signal, like before we use the piece counter, 829. And if you're familiar with controlling the machine, you know that you can show the piece counter on the HMI as well. However, if you're not standing on the machine, you can use the remote access with your browser, again, IP address and port 80 this time, to access the IoT platform of the machine. And here the usage of the Cortex Insights is exactly the same as on the machine HMI. So you filter for your required signal, piece counter 829. This is one of the products that we have.
Very nice, thank you. So another question from the audience. Mm-hmm. What is Cortex Insights used for?
That's a very good question because every product should have a use case behind it. So for us, we use Cortex Insights for our commissioning process because it is a great opportunity to check the logic and scope of the signals after our installation. So we create data with the machine, and then directly with the interface to the database, we can check if the signals are correct. For you, the Cortex Insights provides an interface that you can easily connect to get to the machine data without any specific software or knowledge. Because, for example, if you would like to get some PLC logic or data blocks, you would need a specific software to be able to read the data, and you need some expertise in reading PLC data, which is with Cortex Insights not the case.
All right, so I think now it's the perfect time to take a look into the signal list, because this is the perfect link to the analysis EMAG already has up its sleeve.
All right, so we teased the signal list a little bit before, and now we will take a look at it. This is quite much input, but let me take you through it. For columns, today we look at the description, the left side. Here in the middle we have the value type, which is the name of the signal in the database. And the data type is interesting as well. It gives you a clue about what kind of data it is. Is it a Boolean with alright, not alright? Or is it an integer with a number value behind it, or even a string value? This column is empty. It says if you need an external hardware to collect the data. In a later slide, we see some examples for this. But now let's go through the data itself. So here, first we have some stake light values, red, yellow, and green with on, off, and blinking. Then we have some manual, some control modes for different channels. We have overrides for feed, rapid, and spindles in %. We have some production values like piece counter, as we have taken a look before. We have some status values as well for chucks, air, and hydraulics. And here we see now to collect the signals, there's external hardware or external sensors necessary. So this is not a standard case. On the top side, with the sensors, you get the numbers themselves, and on the bottom side, the Boolean, like all right, not all right. Here we have a bunch of signals that we developed together with a customer for production values like loading and unloading processes. But on the bottom side is the more interesting values, the high frequency data. Data, namely, here are feeds for access, spindle speeds, access positions, current, power, and torque. And these are all data that change in a high frequency, which means that the interface to the database experiences a lot of load. So these signals are only collected at your demand. Usually, we do not collect these signals as a standard use case. Last but not least, we have the tool data, which is also very basic for any type of analysis or visualizations when talking about machine tools. So here as well, provided by us. Now we have an overview about the kind of data and the scope of data that we're talking about, and on basis of which we work with our products. So we were talking about products before. Now I'd like to introduce another product. I'm sure if you have seen any webinars about IoT and EMAG before, you know our dashboard solutions. They provide an easy overview about some key values about your machine. So again, let's take a look at a video. Accessible on the machine itself, on the IoT platform as well, similar to the Cortex Insights. You get, in this case, a standard solution with machine status, the stack light, machine ID, machine type, piece counter with different configured counters in it, and the cycle time with an average of the last 5 parts at the bottom, and in the middle, the last cycle time. And as well as before, accessible from devices outside or devices in the network. Same as Cortex Insights via browser, IP address, port 80. You can access the IoT platform, click on dashboards, and get the same data displayed. So the order and content of the widgets, as we call them, can be configured in different ways. We will see an example about that in a couple of seconds. Yeah?
A question
Yes.
came in. So this is a lot of data. Is it possible to take a look afterwards, or is it just in the moment? How is the procedure?
So the question is talking about historical data, I believe. The dashboards that we provide, which use MQTT. So if you remember from before, display live data only. So it's always a live description of the state of your machine. However, if you want to take a look at past data, you can always access the database with the protocols and ways we have shown you before, and collect the data you wish to review, and then do your own analysis with them. So historical data is accessible in the database.
I think that answered the question pretty good. Thanks.
Then we go one slide ahead. And here we have prepared some more advanced widgets for you, just as a quick overview. What else is possible on basis of our data? So machine status, piece count, and cycle time you have seen before. However, you can notice that the piece count is displayed in two different configurations. OEE is also an often requested value, so we already provide a calculation of the OEE. Health check we have not mentioned so far because there are other webinars covering this topic. Just in general, it is a measurement which collects acceleration data, then calculates a health status about your machine access, and displays the result here. Then tool change, as mentioned before in the signal list, a very basic but yet important key value. This widget displays a countdown for all active tools, so that you can better plan and organize your tool changes.
Very good. Another question came in.
Yes, please.
Do I always need a dashboard for a machine? How do I handle an entire production line with multiple machines here?
Okay, so these were two questions. First question, dashboard per machine. More than one dashboard per machine is not useful because if the machine is a standalone machine with no further connections to other machines, you can provide all the data visible in one dashboard. However, if you have a production line with multiple machines, we have a different solution in mind. If you, as our customer, can provide us an instance in your network where we connect all our machines to, then we have a central storage space for all our machine data. And on this instance, we can then install our dashboard solution and do some analysis over all the machines, which opens up another possibility, a whole new world of possibilities to analyze your data. And this instance is what we call the edge cloud. So this is the solution for multiple machines.
All right. So the dashboard is very clear. There are a lot of information about your machine or your machines. But there are certainly customers, or maybe you are thinking right now, that is not quite sufficient, or your use case is not even thought of yet. And there's where our colleague Axel Dreger comes into play. He has many years of experience in mechanical engineering, especially regarding production processes or production optimization. So he is our customer success manager. In this role, he is here to support our customers. In other words, he is here to help you to generate added value, but with your cooperation in combination with our EDNA IoT products. So he has worked extensively with the database and has independently identified several use cases, which we are talking about in a moment. So Johannes, what did you prepare?
Okay, so we brought 3 use cases that Axel presented to us. However, before we take a look at those, I would like to mention that all the use cases that we see, they are based on real data from real production lines. And Axel has built up these use cases himself, even though he is not a data analyst or similar, which just shows that you can do some analyzations or create use cases to create benefits by yourself, even if you're not an expert with working with data. And in general, the information that you can gather from such use cases is never general, so you always have to map them to your specific process or to your specific machines. So enough talking, let's check the first use case. Here we see listed over 24 hours the tool life of 3 tools. We have a purple one, a pink one, and a brown one. And the lines, the vertical lines are marking the tool changes over the day. And what we can see here as a graph, there are a couple of spots that look a bit odd, and we call those anomalies, which is a interruption from the value adding process. So let's take a closer look at some of those anomalies. Here we see that the pink tool got changed even though it has left half its tool life. The pink tool got changed again too early. Here there's some standstill time that we can see. Again, the purple tool got changed too early, and here there's a rapid drop in tool life of the pink tool, which just means that there are many things that happen over the day with your tool changes. And this is just an indication that this process is not yet fully optimized and can help you to create some more benefits. Then the second example, this one is one I really like personally, because here we have our work pieces listed over 1 hour with the processing time in seconds. And the processing time can be precisely broken down into its singular parts via the colors listed on the description on top. So the green part is where the processing happens. That's our favorite color. We want most of it to be green. Then what we can see in a first glance, there are a couple of red dots, which means that they were waiting times for materials. So there can be a hint that you have missing opportunities. And the measurement is also another point that stands out. So here we have a big unloading time with frequent measurements after it that take up a lot of time. And everything, as said, that's not green is to be minimized. So for example, if you know how much your production line costs for 1 hour of standstill time, you can accumulate the measurement times over a day and then give an answer about how much measuring costs you per day. And if based on the result, you can choose to do some measurements about it, to do some, to work on it. So one example could be that based on the tool wear for each part, you try to replace the measuring by adding the wear to the process for each part. And this could be an easy step to reduce the measurements necessary to still produce good parts. Okay, so let's take a look at it for a couple more seconds. And then switch up to our third and last example. This one is a bit more complex, so stay with me. It just shows that let's start from the beginning. The green values are values that we collect in our database that you can access to. The blue values are some calculations based on those. So you can even do your own calculations to create whole new values. And in this case, we have availability, performance, and quality factor, which themselves build the OEE. So Axel here did an OEE calculation all by himself. And if you can automate this calculation via a script, for example, you can create the live data for your OEE and the underlying factors for each signal that you create in your database, and then create a graph displaying your OEE and the factors beneath it. This is a question that we receive often as well, if you can display the OEE and the factors that result in the OEE. And the answer is yes, you can even do it yourself, as proven by Axel. We do not want to get in further detail about this graph, just as an example, what is possible if you spend enough time and a little bit of creativity with the data. So this is my last slide, and here I try to sum up the information or the key information that we would like to you to remember about this webinar. The gray boxes are what we as EMAG offer you already. We have means of data recording. We have the interface between PLC and EDNA Cortex or other means of including data in our database. We have the data storage, the database included or installed on our IPC locally. We have some means of data visualization already, so that you can get a quick overview about some key values in your production line. And here is where Axel comes in as a data analyst or as a binding point between our solutions and your process. So as you see here, the benefit starts at analyzing the data, which means that IoT does not generate benefits for you, rather than you generate benefits with IoT. And that is the key that you need to understand. So with your expertise, because you are the expert of your process, of your machines, and your creativity and your know-how, in addition with our solutions and help of Axel, you can create benefits. And we have finished some projects with customers already where we had a result of an OEE increase for about 10%, just as a quick idea of what is possible. And with this, I would like to give to you the result.
All right, so we want you to remember to think about data as a chance and not a risk.
Exactly.
And with that, we go to our last slide. So before we come to an end, this is a brief overview of features, packages, services which are already offered in terms of IoT from EMAG. So I'll start at the bottom. EDNA IoT Ready package. With that, you are well equipped in terms of IoT. You have various interfaces to connect to third-party systems. You have the possibility to run initial analysis, and you are prepared for the EDNA health check. Thanks to the ring buffer, you don't start from scratch. You can use the already gathered data from your EMAG machine. Then we have the EDNA Edge Cloud. This is a central storage location and now attention in your network. This has the significant advantage that you have more storage available. Furthermore, through the EDNA Edge Cloud, as mentioned by Johannes earlier, you can compare several machines. EDNA Visualize, which you can see here, is a live transparency of the current production performance. Here in the picture, you see the same apps we already saw in the presentation on our dashboard. And on the top, we have the EDNA Health Check, which gives you information about the health condition of your machine access so that you can implement predictive maintenance. Do you have any more questions for us? We wait some seconds. No, I see there are no more questions. Very good. So thank you for your attention. We hope you had a good webinar with us with getting started with data optimized manufacturing, and you received some helpful information. We both enjoyed it. We had a lot of fun.
Very much so.
So have a great day and a good rest of the week. Take care. See you next time. Bye.